All right, guys. 6.62. We're going to look at the problem number 32 from last night's assignment. Log base 3 of x squared plus 9x plus 27 equals 3. 2. I think I was probably looking at the problem before it. 2. There we go. Now, first main step, because we had 3 steps, one is to get one term on either side. There's one term on either side. It is a logarithm. It has a quadratic inside it, but it is a single term. The other side, too, we do have one term on that side. So next step was to get rid of the log. So we can put both sides to the base of 3, because our 3 to the log base 3 is going to cancel, leaving us with x squared plus 9x plus 27 is equal to, well, 3 to the second power is 9. Now, since we do have a quadratic, we have the x squared term, we need to get this equation equal to 0. So we can subtract 9 from both sides, telling us that x squared plus 9x plus 18 is equal to 0. Now, at this point, we can factor 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and match the sign of the middle term. So plus and plus. Only factors of x squared are x and x. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. And the set of factors that we're going to want are 3 and 6. Zero product property says whenever we have 2 or more things multiplied together that equals 0, one of them has to be 0. For our x plus 3, we would subtract 3 from both sides, giving us x is equal to negative 3. For x plus 6, we subtract 6 from both sides, telling us x is negative 6. So we have negative 3 and negative 6. Now we can plug it back in and make sure that both of these work. Because log base 3, we'd have negative 3 squared plus 9 times negative 3 plus 27. Well, negative 3 squared is 9. 9 times negative 3 would be negative 27 plus 27. We could do 9 minus 27 first, or preferably I would do negative 27 plus 27, which is 0, just giving us log base 3 of 9, which is 2. Because really we're saying 3 to what power is 9? That's all logs are. Log the base, that base number to what power gives us the number inside. 3 to what power is 9? 2. Log base 3 of 9 is 2. If we look at the other value we got, log base 3 of negative 6 squared plus 9 times negative 6 plus 27. Negative 6 squared is going to be 36. 9 times negative 6 is negative 54. Unfortunately, this here, we don't have a nice subtraction like we did on the first one, but a negative 54 plus 27 is actually negative 27. 36 minus 27 is 9. It works. Because again, the reason we're checking is because we cannot have a negative end up in the log. So where the 9 ended up, if that had been negative 9, that solution would not work. We cannot have a negative end up in that log. But that's it. Thank you. Thank you. Questions on this here? Questions on anything we've done so far? All right, we ready for the days? I will tell you this. So the logs that we did in this here from yesterday is going to be almost the exact same thing we do today. We're going to add one step. Because when we look at this here, I'm going to rewrite the 3 steps we had yesterday. One was to get one term on each side. 2, get the variable or variables out of the power or log. And 3 is just solve. Same 3 steps we had yesterday. Now, if we look at this here, the left side of this problem has 2 terms. We needed to have 1. Now, we could try moving one of the logs to the other side, which would give us 1 term on the left side, but then we'd have 2 terms on the right. But we did have log base b of m plus log base b of n is equal to log base b of m times n, our product property. Anytime we have 2 things being multiplied together inside the log, can be rewritten as a sum of 2 logs. Or the reverse is also true. If we have 2 logs with the same base being added, we can rewrite them as a single log with what's inside being multiplied. So log of 2x plus log of x minus 5 is the same as log of 2x times x minus 5. And that right there is really the only new step that's being added. Everything else is going to be the exact same. So looking at this here, that took care of step 1. Step 2 is to get those variables out of the log. But we need to put both sides to a base. What's the base of our log if the base is not written?
2.
It's understood to be 10. LOG's base is 10. LN's base is E. So we're going to put both sides to the base of 10. Because we want this 10 to the log base 10 to simplify. And it will, leaving us with 2x times x minus 5 is equal to 10 squared. 10 times 10 is 100. So really, as we can see here, the only real difference between yesterday and today is just getting those 2 logs put back together. Now at this point here, we can distribute. 2x times x is 2x squared. 2x times 5 is negative 10x is equal to 100. Now, since we have an x squared term, we have an x to a power greater than 1, means we have to get this equation equal to 0. Questions on how we got this equation equal to 0? So there's 3 main ways we can solve this here. We can use the quadratic formula, we can factor it, or we can graph it. I'll show graphing first. Because graphing, we can pull the graphing calculator, hit our y equals, and type it in. 2x squared minus 10x minus 100. Pellet graph. Well, it seems to cross at 2 spots on the x-axis, yes? Second table. We're looking for what values of x make the y value be. 0. So one of them is 10. And the other is, so we can say x is equal to 10 or negative 5. Now we can graph it, or factor it. Because if we factor, we'd factor out the 2. Minus 50 equals 0. Since the third term's negative, our signs would be opposite. Only factors of x squared are x and x. Factors of 50 are 1 and 50, 2 and 25, 4 and 10, or 5 and 10. Well, we'd want positive 5 and negative 10. Two things multiplied together to equal 0. One of them has to be 0. So we're saying that x plus 5 is 0 and x minus 10 is 0. Yes? Because again, the graphing calculator told us it was positive 10 and negative 5. Well, there's a reason we put x with the negative, 5 with the positive. Because what minus 10 gives us 0? Well, positive 10 minus 10 is 0. What added to 5 gives us 0? Well, negative 5. Yeah. Because for x plus 5, we'd minus 5. Lo and behold, telling us x is negative 5. X minus 10, we would add 10, telling us x is 10. Both ways give us the answer, yes? Questions on any of this so far? Before we move on, I want to check my two answers. Because I've said it a few times here, what's inside these logs cannot be negative or 0. Not so much the value we plug in for x, but after we plug it in, its value can't be negative or 0. So if we plug in 10, here, well, 2 times 10 is 20. 10 minus 5 is 5. So after plugging 10 in, the number we get is 20, and the other number we get is 5. Both positive numbers inside the log. This works. And since it is our common log, we can grab either calculator easily and say log of 20 plus log of 5 is 2. But the bigger thing is that the numbers that we ended up inside each of these logs are both positive. They're not 0 or negative. That's the key. Let's look at negative 5. We'd have log of 2 times negative 5 plus log of negative 5 minus 5. Well, 2 times negative 5 is negative 10. Negative 5 minus 5 is negative 10. In both cases, we ended up with a negative inside that log. We cannot take log of a negative number. So what that tells us is that the x equals negative 5 is not a solution. It's an extraneous solution. So the only actual solution that we have for this problem, first one, is x equals 10. We have to get rid of that other solution. Yep. Because it gave us a negative. Now that's not always going to be the negative case. So most of the ones we look at, we're going to end up throwing the negative case out. But that's not always going to be the case. It can be that the negative solution is the solution and the positive is the one we throw out. Because if there's a way in the problem that the negative is able to switch or is be able to correct it to positive, that's going to be the solution. Negative is going to be thrown out. But it is always good to just plug it back in because we're wanting to make sure we don't get a negative number as that last part before we take the log. because if we do, it doesn't work. It doesn't matter if it's in both or only one. It does not work. Does that make sense? All right. Let's look at this next one here. Log base 6 of 6x plus log base 6 of x minus 1 equals 2. We can rewrite these two logs as a single log with what's inside being multiplied. So we can rewrite it as log base 6 of 6x times x minus 1. Now we're going to put both sides to the base of 6. Because we want the 6 of the log base 6 to cancel out, giving us 6x times x minus 1 is equal to 36. Then we would distribute 6x squared minus 6x is equal to 36. Since we have an x squared term, we would subtract 36 from both sides. Minus 6x squared minus 6x minus 36 is equal to 0. Yes. Do we want to graph or factor? Factor. So graphing or factoring, taking out that common factor of 6, can sometimes make it a little bit nicer. It won't change the solutions. It'll change the rest of the graph, but it will keep the same solutions. If we factor out that 6, we get x squared minus x minus 6. Third term is negative, so our signs are opposite. Only factors of x squared are x and x. Factors of 6 that we want: 2 and 3, 2 positive, 3 negative. Yes? Well, I think some of us can at this point see what the two values are. Negative 2 and positive 3. Which one are we most likely going to throw out? Negative 2. Because if we look back at this here, 6 times negative 2 is going to be negative 12. There's nothing that's going to fix that negative. Because if it was 6x squared, it would fix that negative, because a square is going to make it positive. There's nothing to fix it. Because we can even check here, log of base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1 would give us log base 6 of negative 12 plus log base 6 of negative 3. We have negatives in both cases. Can't have that. When x is 3. Six times 3 is 18. 3 minus 2, 1 is 2. Both of those are positive. That's going to work. Because interestingly enough, 18 times 2 is 36. 6 squared is 36. Negative 12 times negative 3 is also positive 36, but it doesn't work in the original problem. So the only one that actually works is 3. Questions on these here? So is this any real different than what we did yesterday? Not really. Do we feel comfortable with these? Okay. we're going to jump to this one here. So we're going to jump several problems. There will not be one of these on the homework. I want to show you this so that you've at least seen it, know what it is, and know that these actually aren't that bad. They seem like they're going to be worse than the other ones, but they're really not. Because our first main step still holds true. We need one term on either side, yes? And we do have a property that says if I have two logs with the same base being subtracted, we can rewrite it as a single log with what's inside being divided. So really, for our log base 4 of x minus log base 4 of x minus 1, we can rewrite as a single log with what's inside them being divided. Questions on this here? Now, with rational expressions, rational equations, we did have restrictions because in our last chapter we talked about rational equations. We can't have any value of x that would make the denominator be 0, yes? Well, that really doesn't, I mean, it plays a part, but doesn't at the same time, because the values of x that would make either the x or x minus 1 be 0 still can't work in the original problem, because logarithms cannot have a value of 0 inside or negative. So anything that would make x minus 1 be 0 for the bottom of this fraction would also make the log be 0. So it's nothing that's being added that we're not already taking care of or checking later. It's not going to be an additional step. At this point here, we're going to put both sides to the base of 4. Because we want this here to cancel, leaving us with x over x minus 1. Now the other side, we have 4 to the 1/2 power, which is 2. Because interestingly enough, the 1/2 power is the same as the square root. So 4 to the 1/2 is the same as the square root of 4, which is 2. Now we need to solve for x, yes? Well, it'd be nice to get this fraction simplified. Well, we can do it by multiplying it by x minus 1, because that x minus 1 would go on top. X minus 1 over x minus 1 would cancel, leaving us with x. But if we multiply it on one side, we got to do it to the other. 2 times x is 2x. 2 times negative 1 is 2 minus 2. Do we have an x to a power greater than 1? No. So we don't have to get this equation equal to 0. We can just get the x's on one side, numbers on the other, and solve. I can just minus 2x. X minus 2x is negative x. So negative x equals negative 2. Yes. Excuse me. Well, if I know negative x equals negative 2, positive x should equal positive 2. If I flip the sign on one, I have to flip the sign on the other. One option is that we could divide both sides by negative 1. Negative x divided by negative 1 is x. Negative 2 divided by negative 1 is 2. Or if we want to, we can multiply everything by negative 1, get to the exact same place. Negative 1 times negative x, positive x. Negative 2 times negative 1 is positive 2. Same place. But I just wanted to show you all that so that y'all have at least seen it. Okay? Questions on any of this here? We have one last problem and we're done. So, get to the page with this problem on it, yes? And right below it, we're going to write this. This problem isn't any different. We're just using natural logs instead of logs. Only difference. Because our first main step is going to be the same as before. We're going to rewrite these two logs as a single log with what's inside being multiplied. Now, what base are we going to put both sides to? E. Because e to the ln will cancel out, leaving us with x times x minus 5 is equal to, what is e to the third? A very rough number, yes. E is irrational, so e to the third power is also irrational. So we're going to leave it as e to the third. But that's also going to cause some issues. Because when we factor, we don't factor irrational numbers. That's why when we had the quadratics in our higher degree polynomials, if we had an irrational number, we couldn't factor, we couldn't graph. We had to use the quadratic formula. Which means for this here, we're going to have to get this equation most likely equal to 0 and use the quadratic formula for it. Most of what we'll end up having to do is going to be setup and then calculator. So the first thing we can do is distribute the x. X times x is x squared. X times negative 5 is negative 5x. We can subtract e to the third from both sides, giving us x squared minus 5x minus e to the third is equal to 0. Because e to the third is still a number. It's an irrational number, but it is still a number. So the next main part that we're going to have to do is we are going to need to use the quadratic formula. We're going to plug the values in and mainly work it so we get something that's nicer to put in the calculator. We're not throwing a ton of terms in. Now for us here, negative b. Well, the b value for us is what? Negative 5. It's the number in front of x. So we have negative negative 5. Plus or minus a square root. So b squared would be negative 5 squared. Minus 4 times a. A is the number in front of x squared, which is 1. Now c is our number without a variable. What's our value of c going to be? Yeah, it's going to be negative e to the third. All over 2 times a, or 2 times 1. Now, I personally think that'd be a lot to try to type in all at once, yes? Let's look at some of the things we can simplify. Negative negative 5. That's just 5. On bottom, 2 times 1 is 2. Let's look at inside that radical. Negative 5 squared. Well, negative 5 times negative 5, 25. Over here, we have negative 4 times 1 times negative e to the third. Well, negative 4 times 1 is negative 4, yes? Negative times that negative in the e is going to make that positive, yes? And all we have left is 4 times e to the third. Which is just 4e to the third. It does have a specific value, but that value is also irrational. But at this point, this is a little bit nicer to type in than the one we had before, yes? All right. Questions on how we got to here? up to this point, we've had at least one solution that worked and one that didn't. So there are technically two solutions here. One of these is 5 plus the square root of 25 plus 4e cubed all over 2. And the other is 5 minus the square root of 25 plus 4e cubed all over 2. One of these solutions is going to work, and one of them is not. And this is where the calculator comes in, because now we can just throw all this in. 5 plus the square root of 25 plus 4. To get e, we use the ln button. E to the x, e to the third. All over 2 is this number here. 7.631816143. We'll go 3 places, 7.362. Questions on how we type that in there? Well, now we need to check the other one, yes? There is one nice thing about both the calculators that we use. If I go back up, use the arrows to select the one we typed in first, go over and change the plus to a minus. All you got to do is hit enter, and there's the other one. That's the nice thing about the recall button. Unfortunately, the 83 plus calculators don't have that, which stinks. 84s, the graphing do. Negative 2.632. 362, right? 632, yeah. Flip. So these are our two solutions. Which one do you think is not going to work? The negative. Because if we look back up here, the ln of x, there's no way to get that negative for that negative value to be positive. It's just going to be the natural log of negative 2.362. I can't have a log of a negative. 7.362. So we can check the other one. Because luckily with logs, 0.632. I had that right. Okay. It is 632. Did I have it flipped?
The bottom one was 632, but the 7. Oh no, they were both 632. Okay.
Yeah, I had it. Now, one thing that is interesting, and the ones on the homework, I'll point this out, that decimal number will stay the same. It will still be the same decimal. The number in front of it's going to change, but the decimal normally stays the same. 632, yeah. Okay. Plus natural log of 7.632 minus 5. And this is going to give us what? Was 7.632 the full value of our x? Well, no, we rounded it to the third spot, yes? Which means we're not plugging in the exact value of x, we're plugging in an approximate value of x. That's why we don't get exactly 3, because it's not close enough to give us 3, but it is close enough to say that yes, this is the solution. Because the more value of x is that we plug in, the closer that this would get to our actual value. Yeah. Let's take that value, store it in x. The natural log of x plus natural log of x minus 5 is 3. So the more decimal values we put in, the closer it would get to our actual value. All right. Questions on this here? We're ready for the homework. (33 through 37). 2 of them are going to be the natural logs. 33 and 34, you'll get an exact number answer. 35, 36, we're going to have to use quadratic formula. And I will tell you this here, 37, you will get 2 solutions. Both of them will work.
What part is the quadratic?
So the quadratic equation,
Which numbers?
35, 36, because that ln, the natural log, since we have to put both sides to the base e, that e to a number is not going to simplify nicely. The only time it would is if it was like e to the 0. E to the 0 power would be 1. Then it would work out nicely. Otherwise, we're going to have to approximate. Section left.